Let's look at this set. 5 friends named MNOPQ played a game in which they had to choose one card each from 2 different stacks. The numbers written on the 5 different cards selected by MNOPQ were 3, 6, 8, 10, 12 respectively. The numbers written on the other 5 cards selected by them were 4, 6, 9, 12, 15 in no particular order. The order of each person, the score of each person was calculated by multiplying the numbers. So, a comprehensive list of values that are being obtained by them will be given in the following manner. We have 3, we have 6, we have 8, we have 10, we have 12. These are M, N, O, P, Q. And then the potential values that they can get will be coming from 4, 6, 9, 12, and 15. So we get 12, 24, 32, 40, and 48. Here we get 18, 36, 48, 60, and 72. Now, here we will get 27, 54, 72, 90, and 108. And then from 12 we'll get 36, 72, 96, 120, and 144. And finally, 45, 90, 120, 120, 150, and 180. Okay. Now let's get to individual questions. Which of these can be the sum of any which of these can be the sum of scores of any 2 friends if most of them score more than 100? If most of them score more than 100, I'll see Q can score more than 100, whether he gets paired up with 9 or 12 or 15. P can score more than 100 if he gets paired up with 12 or 15. And Q can score more than 100 only if he gets paired up with 15. N can never score more than 100. M can never score more than 100. So most of them scoring more than 100 would imply O gets to 120 and P gets to 120 also, and Q gets to 108. Now most of them have scored greater than 100, but M and N will not score more than 100. Now M and N not scoring more than 100, the only columns left available for them are 4 and 6. So either we'll have 12 and 36 pairing up, or we'll have 24 and 18 pairing up. So the potential sums are 48 or 42. Now, when they ask me which of these can be the sum, the answer has to be either 48 or 42. When M is 12 and N is 36, that is when we get 48. So option B should be the answer. Next question. If it is known that more than one friend scored equal marks, which was equal to X, and that X was not the lowest or the highest mark scored by any student, how many possible values of X exist? Okay. So basically common values you have to see. If we end up with, let's say, first column and second column or numbers that are identical, I simply highlight them. I see 48 is here and 48 is here. This can be one pairing. Another pairing I see 72 here and 72 here. This can be another pairing. I see anything else? Oh, I also see a 72 here. 120 we had already seen. 120 or 120. And finally, we can also see 90 and 90. These are the scores which are identical. These are the scores which are identical. Now, if 48 and 48 was common, then I need a score lower than 48. I can get it 27 from here. I also need a score higher than 48. I can get 150 from here. See, all I'm ensuring is Once I've taken this 48, I don't take any number from this row or any number from this column. Then when I've taken this 48, no number from this row or no number from this column. So I can have 27, I can have 150. So 48 gone, 27 gone, 150 gone. So the only number left for this is 72. This way 48 is a possible viable pair where two friends have identical scores and they're neither the highest nor the lowest. What about 72? Let's say I take 72 here and I take 72 here for the 6 column and 9 column. Then I can have 12 here, 72, 72 1. I can have 150 here, 72, 72, 12, 150. So for here, this one, for 12, you will also have a 72. 72 is also possible. 72 is also possible. Wonderful. How about 90? I take 90 here and I take 90 here. Then I can get 144 here, or even 96 would be fine, but I'm deliberately taking the largest value. 144 can be taken here. Here I will take 48. Here I will take 12. 12 and 48. This is also fine. No problem at all. 90 can also be a value that is identical. Now 120. Can I take 120 as the same thing? 120 can't be taken. 120 green value cannot be taken, because if I take 120 here and 120 here, I cannot get a value greater than 120. So that is out. Okay. So that should lead me to the answer of 3, but I have made a mistake. The mistake being, look at this. Can you see we also have a 36 available here and we have a 36 available here. This 120 pairing is not enough. This 120 pairing does not get me there, but 36 and 36 and 72 and 72 not there. I need a value lower than 36 now. I have taken 36, I can get 32 here, I can get 90 here, and I can get 180 here. So two values being identical, they are neither the largest nor the strongest. This is a possible case, this is a possible case, this is a possible case, this is a possible case. So there are 4 possible values of x that exist. While 120 and 120 is also being repeated, you cannot have 120 as either not the highest or not the lowest. It will always necessarily be the highest if 120 is repeated. So that will not be counted. The answer to the question will be option C. Okay, next question. It was observed that 2 pairs of friends got the same score. 2 pairs of friends got the same score. Find the score of the friend who scored the least. So now, if 2 pairs of friends scored the same score, 2 pairs. So there are, let's say, 2 scores are identical here and 2 scores are identical here. How can I do it? I can do it 90 and 90 and 48 and 48. 48, 48, 90 and 90. Because see, neither of them intersect with each other in terms of columns, or neither of them intersect with each other in columns or what? 48, this 48, this 48, this 90, this 90. So what is left is the 4th column in the first row. So the smallest value involved has to be 36. The wonderful thing about this question is I don't even have to look for another case, because this is a theta question. As soon as I find one acceptable case, that has to be the answer. Answer to question 3 is 36. Next, find the minimum possible score of all the candidates combined if the number of digits in the first card was equal to the number of digits on the second card for each of the friends. Okay, which means, see, PQ have 10 and 12, and they can only be paired up with 12 and 15. So either it is 12 here, 15 here, or we can have 10 and 12 pairing up with 15 and 12. This will also serve as a benchmark for a different process. See, here I get 120, here I get 180. So the total turns out to be 300. And here 150 plus 144, total turns out to be 294. Now see how these two have been generated. The smallest number has been paired up with the smallest number, and the smallest number has been paired up with the largest number. Row-wise smallest number and column-wise smallest number, row-wise smallest number and column-wise largest number. In which case are we getting a minimal sum? When the smallest number has been paired up with the largest number. This gives us an idea how the pairing for M, N, and O should happen. Their numbers are 3, 6, 8. But when the smallest number gets paired up with the largest number, that is when you get the minimum sum. So this should be 9, this should be 6, and this should be 4. So here we get 27, here we get 36, here we get 32. So 36 plus 32 is 68, 68 plus 27 is 95. So we get 294 plus 95. Final answer will be 389. This will be the minimal possible sum of all the 5 combined with the given conditions, and that is the entirety of this set.